All right, moving on to the next set of problems, the next page. We have a 100 Newton weight suspended by the two cords shown in the figure above, and we want to find the tension T in the horizontal cord. I'm going to call this T, I'm going to call this T1, and I'm going to solve. So the free body diagram of this situation looks like this. I have T1, I have T going horizontally, and I have a 100 Newton weight going down. Now this here is a 30-degree angle as well. And what I need to do is I need to split T1 into two components. So I'm going to have, whoops, let me do that as a dotted line. And I'll do it in blue. So I'll have T1y, and I'll have here T1x. Now T1y is going to end up being T1 times the cosine of 30, T1 times the sine of 30, and T1x is going to be T1 times the cosine of 30. Now what we need to do is we need to go ahead and set up our equations in the x and y direction. Well, in the vertical direction, we're going to have T1 sine of 30 minus the weight balances. That should just be a 0. And in the x direction, we're going to have an equation that speaks to the horizontal direction. It's going to be T1 cosine of 30 minus the t that we're solving for equals 0. So we may actually have to do this in two steps. So first, we're going to have T1 times the sine of 30, which is 0.5, minus 100, the weight, equals 0. So I'm getting that T is actually, in fact, 200 newtons. Then we're going to have T1. That's T1 that I've just solved for. Apologize for that. And then we're going to have T1, so 200 times the cosine of 30 minus T equals 0. So when we end up solving for T by doing this math, we're going to get T equals 173 newtons. Excellent. Now, on to a couple free response. So we want to draw the free body diagram. We'll assume there's friction on all surfaces unless they tell us. So we're going to have weight, we're going to have tension, we're going to have a normal force, and we'll assume it wants to slide down, so we'd actually put a friction force this way. Now, ball rising in a parabolic trajectory, the only force acting downwards is weight. Finally, for this last one, we're going to end up having a force here going at an angle theta. We have the weight, we have the normal, and we have the force of kinetic friction going backwards. So that's it for this page, and we will take up our discussion in the next page in a few moments.